This is one of my favorite parts of the Pythagorean theorem. It's primarily about sides, but the amazing thing is we can use it to classify a triangle by angles. So using the Pythagorean theorem and the value of the leg lengths, I can tell if a triangle is acute, obtuse, or right. So how does this work? Let's go ahead and take a look at an example where I have a 3, 5, 7 triangle. I've constructed it so I'm pretending it's a right triangle. Here's my leg of length 3, leg of length 5, and my long leg of length 7. I'm going to pretend that's going to be my hypotenuse. So we'll use the Pythagorean theorem. First of all, we're going to find a squared plus b squared, which in this case will be 3 squared plus 5 squared because I put in the two smallest legs. Then I add a square and add those. 9 plus 25 is 34. Next, I'm going to find c squared. The longest leg is 7, so it's 7 squared, or 49. So what does it mean when c squared is too big? Well, okay, so I have my a squared plus b squared is 34, and my c squared is 49. And these are the legs that generated those. Well, if I start to slide this down, and you can see how this circle shows me all the different ways I can orient this side. I'm going to slide it down to meet this other side. Well, since c squared is too big, this side, it's going to hit and you're going to have it overlapping. So I need to swing out this leg of length 3, and I can keep trying to get it closer and closer together. And you can probably tell by using the circles, which are kind of like a compass, you can guess where they're actually going to meet. So now I had to swing out one of the legs and then swing down the long leg. Because I swung out the leg, and that was originally a 90-degree angle there, that means my angle, the biggest angle in this triangle, is now obtuse. So if the biggest angle is obtuse, that means the triangle's obtuse. So if c squared is too big, the triangle is obtuse. Now we're looking at a 5, 6, 7 triangle. So the legs are a little bit longer for the short sides. I'm still going to find a squared plus b squared, which would be 5 squared plus 6 squared, 25 plus 36, which is 61. That I'm still going to square the longest side, which is a 7, so I get 49. So in this case, you can see that 49, the c squared, is smaller than the a squared plus b squared. What does it mean when c squared is too small? Well, you can probably guess. I've got this sort of compass setting here. You can see everywhere I can move this leg. And if I move it to meet the small leg over here, it doesn't match up. So you can probably guess I'm going to have to move this out and bring in this leg until I can make them both meet. And there we go. We have our triangle. Now the largest angle is still this angle here. Why? Because it's opposite the longest side, which is 7. But I can also tell that this angle is no longer 90 degrees. In fact, it's less than 90 degrees. Since my largest angle is less than 90 degrees, the triangle is acute. This brings us to the converse of the Pythagorean theorem, which says if c squared equals a squared plus b squared, the triangle is a right triangle. If it's less than, the triangle is acute. And if c squared is greater than or too big, the triangle is obtuse. So we'll apply this in this example. We're going to classify some triangles by using the sides. First of all, it's always good to make sure they do make triangles. In this case, they do. And I'm going to identify my A, B, and C. So first of all, I'm going to do my c squared. 7.5 is my longest side. I square that, I get 56.25. Now I substitute in my two shorter legs, 4 squared and 7 squared. 16 plus 49 is 61. C squared in this case is too small, so the triangle is acute. We're going to do the same thing for this next triangle. Notice that the longest leg is in the middle there. It's 25. I need to use that for my c squared. 25 squared is 625. Squaring the two shorter sides, I get 24 squared plus 7 squared, or 576 plus 49, which happens to be 625. In this case, c squared is just right. When it's just right, it's a right triangle. So for further reflection, if c squared is greater than a squared plus b squared, so that means c squared is too big, what does that tell you about the triangle? If c squared is too small, what does that tell you about the triangle?